Hi, I'm Dylan Pavelka,
Hi, I'm Jacob Power.
and we have a DMX 512 theater light controller that senses colored light. The short name for this is P squared. So there's a number of different things that we have going on. This is our colored light sensor here that's based on the Project 3 sensor project. This ends up going to our Nexus board, which drives a power supply for an LED fixture using DMX 512. Which is right here. These are both commercial products. We obviously did not make these in the 2 weeks. So what it does is it grabs the color qualities of the light, red, green, blue, and white, and sends it to our Nexus board, and then we use a fixture that has red, green, and blue LEDs inside of it to reproduce that color. It also has a number of functions, including a live mode, so whatever color the sensor sees, it will put out. You'll be able to play back colors that we've pre-stored. You can store new colors in case you want to have a color play that we haven't already set up for you. And we also have an identification, so you can put a color up and it will tell you what color you're looking at.
So to do all this, we used quite a few Xilinx IP module cores. First of all, we used I2C to talk to the color light sensor, which is on this cord here. Additionally, the DMX interface, DMX is basically just based on the RS-485 signaling protocol. That's coming off of GPIO, which Dylan wrote this really cool driver for. Additionally, we're using UART to, so this project has two user interfaces actually, which is one of the cool parts. So we designed it so you can either use it in a standalone mode where you don't have a computer with you, so it's just your Nexus board and there's a little UI that runs on the LCD screen, the buttons and the switches, or there's another mode in which it outputs using RS-232 and a UART to a computer terminal, and it has a full user interface where you can modify settings and set it up and store new colors and stuff. So what we're going to do now is demonstrate the computer-based UI. We could also show you the one on the device, but it's really boring compared to the computer one, which is actually a lot cooler. So here, I'll pull it up now. It's in PuTTY, which is just a terminal program. So here's the main menu for it. And you want to do live mode first?
Let's start with live mode.
Where's the fixture?
Fixture's on the ground.
Okay, so the screen. Okay, cool. So first we're going to do live.
Live. So the way live mode works is it gets the colors and puts it straight out to DMX. We've already calibrated it, so this is just kind of screen and ambient light. And now there's not going to turn the light off.
Oh, that's fine.
No, that's fine. If that's what it should do. And I put a pink gel on it. Gels are used in theater applications to color lights, and it reproduces the pink color. I could put a different gel color. This is a blue color, and it reproduces that color as well. So the next thing we're going to show is color playback. So we pre-stored some colors in there just in case we want to use one of these. And so let's just go ahead and play like lights sample.
Okay.
Go 40.
So what we have over here is the first number is the index number, which it's stored by in the program memory, and then after that it says basically the full ASCII name of whatever we stored it as. So in this case we're using like R for Roscoe, the Roscoe number and the name of the color. So here, what did you want?
Light sample.
Oh, that's 4. So then you do 4, and then it sends that to the fixture.
So another thing that you can do, in case say you don't want to use some of the 6 colors we have space for new colors to be programmed. So we're going to go ahead and program a lavender color right now. I simply put the color on top of the sensor.
Press enter. It takes a sampling from the sensor, stores that in its memory. It says it's going to be stored as index number 7, and you type in a name for it, which is 16 characters or less, so it will also fit on the LCD if necessary. We're going to do R57. Lavender. Hit enter. It saves it. And then if you go to gel playback, it's added under user stored colors. You get 7, and it reproduces the color pretty well, actually.
Some colors, because of the sensor and the LED fixtures, some colors don't reproduce as well as other colors. So we're showing you ones that look nice.
Yeah, the fixture and the sensor are kind of weak in green, so greens are pretty bad on there, but the reds and blues are very solid on the reproduction.
So just to show off one more feature that we have, the color identification. You can get a color, if I can find some that I know have pre-programmed in here. So you can choose one of the gels that have been programmed in, either ones that you've programmed in or ones that were pre-programmed in. And you simply put the gel in front of the sensor.
And so if I hit enter,
it
says...
And it recognizes that I've put aquamarine in front of it. If I put a different color, it recognizes that with dark amber. The dark bastard name was on it.
And then the final mode, which was sort of more of a testing feature, but we left it in because it was actually pretty useful, is full manual control, which is basically you can send raw data to the fixture, and then you can, it's entirely based not on the computer terminal, but it's based on the switches of the Nexus board, but you can actually directly write red, green, and blue components in line. So that's what he's demoing right now, produce two colors.
And that's our project.
That's about it.
Great. Thanks, guys.